If you've ever copied a Redstone build block by block and the moment it breaks down you have no idea how to fix it, it's because you don't understand logic gates. These 6 simple gates are the building blocks for almost every Redstone machine in Minecraft. First up is the AND gate. An AND gate only outputs a signal when both inputs are on. So if we have 2 levers controlling a lamp, if lever A is on but lever B is off, nothing happens. And if lever B is on and lever A is off, still nothing. But when both levers are turned on, the output activates. Next is the OR gate. An OR gate activates if any input is on. So if lever A turns on, the output activates. If lever B turns on, the output also activates. If both are on, still activates. The only time it's off is when both inputs are also off. Now we have the NOT gate, also called an inverter. This one flips the signal. If the input is on, the output becomes off. If the input is off, the output becomes on. Next is the NAND gate. This one is basically the opposite of an AND gate. It's as if you stuck a NOT gate on the end of an AND gate. The only time the output turns off is when both inputs are on. So if neither input is on, the output stays on. If either lever A or lever B is on, then the output also stays on. But if both levers are on at the same time, then the output shuts off. Next is the NOR gate. This one is the opposite of an OR gate. It's similar to the NAND gate as it's comprised of both an OR gate and a NOT gate. A NOR gate only turns on when both inputs are off. So if either or both inputs are turned on, then the output shuts off. Finally, we have the XOR gate, which stands for exclusive OR. This gate turns on when the inputs are different. If lever A is on and lever B is off, the output turns on. If lever B is on and lever A is off, the output also turns on. But if both levers are on or both are off, the output turns off. Now it's time to look at how some of the different versions of these gates are actually made, as well as seeing these gates in action. You might have been using these logic gates without even realizing it. Alright, first up is our first AND gate, very basic. As you can see, if both inputs are on, the output is on, but if either is off, then it's also off. How it works is the power goes into these torches here, which either powers or depowers this redstone, which then affects this torch here. So if one goes on and this turns off, which affects your output here. Next up is the vertical version. So we have 2 inputs here on the green, and they power these torches here. So if this turns on, it depowers this torch here, which then affects this redstone here. When this redstone affects this torch here, it's either on or off, which then goes to our output. So as you can see, when both are on, it means this one in the back also turns on the output. Finally, we have a multi-input one. So if all of these levers are turned on, it means all of these torches are turned off, which depowers this redstone line, which powers this torch back up, allowing it to go to the output. Now here's the first one I just showed you, but we can easily turn this into a NAND gate. All we have to do is remove this inverter. Now we have both are off, but it's actually on. But to turn it on, we have to turn both these on, and that turns it off. So all these kind of use an inverter in it already, so you have to remove the inverter to make it a NAND gate. Now let's see this guy in action. So we have a multi-combination lock for a piston door here. Only if we hit the right combination of levers will it actually open. So for this one it's A, C, and D. As you can see, it opens and we're free to leave. This one also has a little bit of extra redstone to stop you from just flicking on all the outputs to open it up. Next up we have our OR gate, which basically means if any of these 3 are powered, it powers the main line, which then powers our output. We also have the vertical composition for this one as well, where if either one, so this one just goes directly into the output, whereas this one goes up and does a bunch of torch powering, which then also allows it, which either or both. Now like the NAND gate, all you have to do is invert the signal, so we have these guys powering through to here to this torch, so the default is on, but if any of these turn on, the power goes through here, flipping this torch, which depowers the redstone. And finally, our little example here is we have just a nice piston door that's activated by a button, and it's activatable on both sides actually. That's how the OR gate works. Now the NOT gate isn't used as its own kind of redstone thing, it's usually used in unison with other bits, but all it is you power a redstone torch which depowers it, and then you have your output. So it's just the invert of whatever you want. You can see this is now powered and this is depowered. There are many ways of actually doing it, like this one here, which uses like vertical to go up a little bit, or this crazy one which uses comparators, hoppers, and pistons to do it much quicker. This one is actually called a zero tick, where these ones are like 2 tick long, so this one's a little bit faster but a lot more advanced. And finally, the example of the NOT gate is actually a sorter. As you can see here, it's currently powering these hoppers, which means nothing can actually go through them. But if you depower it, which is using the NOT gate, so an inverter allows it to depower these, which allows your items to be sorted into here. Now, finally, for the exclusive OR gate, this one uses a lot of torches. As you can see here, if we flip on the first lever, it's going to depower these guys, which is then going to power this one, giving our output the positive. Same for the other side, it's just a copy on the other side, but if both are on, then this signal goes on here, which powers both sides, which turns it off. And it's the exact same when both are on. If these are on, then these are also off. You can also use observers and pistons for short little pulses like this one. As you can see, it's a single pulse, which means the sticky piston didn't hold on to the redstone. Now if I go over to this one, it's going to pull it back. So see, you can see both are on, but our power is off. And if both are off, then the power is also off. But if either of them are individually on, then our power is on. Finally, for our example, you can imagine you have a long tunnel with lights in the top. You want to turn them on when you're entering the tunnel, but once you leave that hallway, you want to turn it off, but you don't want to go all the way back to the start to turn it off. Now, if you use an XOR gate, you can turn this one on, and it also turns everything off in the corridor. Now, those are the 6 core logic gates used in Minecraft Redstone. Once you understand these, Redstone becomes a lot easier to design, because almost every machine is just a different combination of these same simple circuits. Now, if you want to learn more about Minecraft Redstone, leave a comment about what I should look into next, and make sure to like and subscribe for more videos coming soon. Until next time.